How you doing, everybody? Greetings and welcome to today's episode of 8 Binary Digits in the Basement, where I have a little bit of a treat in store for you. Now, maybe you've never heard of this unit before, or even if you have heard of it, maybe you've never actually touched one of them before. But this guy here is a Thomson MO5. And Thomson made a whole range of computers, but only really here in France. It was the only place where these were popular. They made the MO5, as you see here. There was an upgraded version with a mechanical keyboard as well. There was also an MO6, and they also made a range called the TO, which was a little bit more technologically advanced. There was the TO7, the TO770, the TO8, and the TO9. And the reason that Thomson made all these was that back in the early 80s, they won a contract with the French government to supply computers for their Informatique pour tous program, which is information technology for everyone, which is very, very much like what the BBC did in the UK back in the 1980s. So in a way, this Thomson MO5 is the French equivalent of the English BBC Micro. And this particular model here, I picked up on eBay for a princely sum of only €30. And the guy that was selling them, he had 9 of them to sell. And he was looking to shift them fairly quick. And I think that it was a stock that was left over in the storeroom in the school somewhere. And the reason I say that is that it came with 2 accessories. I showed those to you. First of all, it came with this guy here, which is boîtier de communication. And written on it is nano réseau. And what that is it's a communications box that is used to make up what is called a micro network or a nano network. And if the MO5 was in a school, for example, a teacher preparing his class could, use an IBM PC, or compatible at the time, load a program onto like 30 different systems all at once if they contained one of these boxes. So these boxes would really only have been used in schools. So that's the number one reason why I think this guy here came from a school somewhere. The second thing it came with was this guy here. It's a Thomson 64 kilobyte memory expansion little box. So I'm not sure if it actually contains 64 kilobytes of RAM or if it contains 16 kilobytes of RAM to bring the MO5's 48K up to 64. But in any case, I found very, very little information about this particular box on the internet, and I have seen no software where they say you must have this in order to make it work. So I'm not sure what the reason behind that little 64 kilobyte expansion is. But what the system didn't come with was a power supply. And it takes a kind of uncommon type of power. It needs 17 volts DC with a center negative. And I don't really have anything that's 17 volt DC. So we'll have a look around and see what kind of solution we can come up with to power this little beast. Okay, so we hit one of the parts I like the most actually in any of these system tests is to try and make up a power supply for a unit that we don't have a power supply for. So the little MO5 needs 17 volts of DC current to power it. Now, I don't have anything anywhere near 17 volts. The best I can do is this PC power supply. So this guy will give me 3.3, 5, 12, or a negative 12 volts. Again, it's nowhere near the 17 volts that I need. But if you take a look here, you can see that I'm getting 12 volts from the yellow wire here on this little Molex connector. So luckily, what I have is this guy here. It's an XL6009E1, and it's a step-up transformer. And what it does is we can feed a voltage in. So what I'm going to do, having snipped this little splitter cable for a Molex, is I'm going to take 12 volts into it here. And by turning this little potentiometer here, we can output whatever voltage we want to this barrel jack that I've put on. And I've made sure to wire it up in such a way that the center is given the negative and the exterior of the barrel jack is given the positive. So what we'll do is we'll plug this guy into the power supply, and then we'll turn this knob until we get our 17 volts. But actually 17 volts isn't exactly what we need, because I had a look around on the internet, which is always a very good thing to do. And there is a site that I'll put a link to in the description that says, in fact, the power supplies that came with the MO5 were kind of erratic, and they gave anything up to 21 volts. and it worked away fine with it. But in fact, all it needs is about 15 volts in order to power it, and that'll also extend what life the system has left. So what we'll do is we'll adjust this in such a way that it's given just over 15 volts, and that should be exactly what we need in order to power this system. So I'm after setting myself up. I'm after plugging this little XL device into the 12 volt line on the PC power supply, and as you can see here, we're still getting like 12.8 volts through it. So what I'm going to do is I'm going to adjust this potentiometer, and hopefully you'll be able to see what happens as I turn it up. Okay, I'm going the wrong way. Turn this way, we're up to 13. There we go. Okay, so we've turned it and we're up to 15.3 volts. So we are getting 15.3 volts out through this barrel jack from this guy here. And as I have the negative probe stuck into the center and the positive probe touching the outside, and we're getting a positive voltage here, we know that it's center negative. So everything is set up the way it should be. The next step is to plug it into the MO5 and see does it actually work. Now, so we're at the point where we can plug this guy in and see does it work or not. And to be honest, I've already opened it up. I've checked on the inside, made sure that the capacitors were okay and there was nothing in there that would prevent it from powering up, from a glance at least. And I'll show you all that in a little while. But I thought what we'd do first is we'd have a little look on the outside of the system just to get a feel for it. So looking at the top of the system here, what we see is it's a Thomson MO5. That's plain to see to anyone. MO5 is printed here in a nice yellow outlined font just below the cartridge port. And this here is the port where we would stick in that 64K memory expansion. Here there's a little initialize program button, which is like a soft reset for the system. Over here it's marked UC50.001. And it's got Thomson and their little trademark here beside it. Now looking at the keyboard, it's a French AZERTY keyboard layout, which makes sense. This was for French schools. And it's using a little rubber keyboard, very much like the ZX Spectrum had, but the keys are larger than the Spectrum had and they're also easier to press. So that's a plus, I suppose, in a way. But it's got 58 keys, and you'll see straight away there's a yellow one down here and there's a black one down here. So the yellow key will give you access to any of these little yellow symbols you see on the top right hand side of some of the keys. So we've got likes of little caret, a greater than and less than sign, and then we've got our inverted commas, our exclamation mark, and a few different ones like that. The black one here will give us access to basic keystrokes. I suppose what we've got here is, for example, if we press that and we press F, we get for. G, we get go. H, we get sub. Very much again like the ZX Spectrum, but the difference is you don't have to use that. You can type in the commands individually with individual letters and they'll work away just fine. Again, the second reason I say that this system must have came from the school is that you see keys over here that are often used, like the enter key and also the right arrow here, are completely rubbed away. So it's been used an awful lot. It was either very, very well loved by someone, or it was in a school somewhere and used each and every day. One other little thing, you see that some of these keys actually have instructions printed on them in French. For example, here we have EFF, which stands for efface, or to delete or rub out. So that there is like our backspace key, and I'll show you how that works in a moment. Here we have RAS, which is remise à zéro, and that guy there to me would mean reset, but in this case it doesn't. It actually works as a clear screen, or the same as a CLS command. So that's pretty much the keyboard on the unit. It's nice to use, but if it was mechanical it would be better. On this side of the system there is absolutely nothing. On the front of the system there's nothing either. Over here on this side we have two DIN ports, each with 5 pins, but they're arranged differently so that they can't be mixed up. This one here on the left hand side is for a light pen, because the Thomson range of computers all supported light pens. So you would plug a light pen in here, and then software came on either cartridge or cassette that would let you draw pictures or press on stuff on screen in the program. But you needed to have a CRT TV in order to use that. A modern day LCD won't work. On the right hand side here, we have a cassette port so that we can load up programs and whatnot from cassette. On the back of the system, I just pull this cable out a little, we've got our power in here. Now there's no power switch on this system. Again, very much like the Spectrum or the Acorn Electron, you need to plug out and plug in the actual physical barrel connector in order to get power on the system. Over here we've got our TV connectors. So this is a SCART cable that's hardwired in, it can't be removed. It plugs into a SCART port on the back of your TV, and as soon as you power on, you get a lovely crisp, clear picture on your screen, which is the same of many French computers of the time. And here what we have is an exposed edge connector. And this guy was used for the likes of the little micro network or micro Rizzo card or box that I showed you there earlier. But there was also a speech synthesizer available for it. There was also a disk controller available for it. And there was a game pack, or not a game pack, but a kind of game adapter which had 2 joy ports and also supported 6-bit sound. And there were a few other devices as well available for it, but only one thing could be plugged in at a time. So there was a kind of a multi-port that could be plugged in to allow you to plug in 2 or more things at a time. But that is pretty much the system on the outside. So I figured what we do is we'll plug it in and I'll show it to you working. So we're after making up our power supply, and we will plug in our 15 volts right now. And here we are. It works away quite well. We've got a turquoise background. We've got blue text on screen that's telling us MO5 Basic version 1, copyright Microsoft 1984. And it gives us an OK prompt. Now from here we can type in whatever we want. So we'll do a little hello world program, for example. So what I'll do is 10 print, our yellow key and our 2 there. And we'll put in just hello. And 20, and I will use our key commands here. I'll do G and T, go to 10, and finally basic and run, and press enter, and there we go. We've got hello running right the way down the screen. Now I'm going to be completely honest with you, I don't know how to stop this. I don't know how to break out of it. When I press stop, it stops, but if I press any key, it starts off again. And it seems that no matter how often I press stop or whatever, I cannot get out of the damn thing. So the only way I can find for the moment to get out is to actually power it down and to power it back on again. But there we go. So I'll show you one other little thing that I figured with this thing that's kind of strange. If you make a mistake, for example, and you want to delete some characters, you use the arrow key to go back, and then you use the efface key to delete that. That's the only real way we can delete on this system. But that's a little look at the system. There are many commands on it. You can change colors and all that kind of stuff, as well as you can with any computer of the time. But I think the next thing really we should do is look at connecting this guy up to some kind of device and see if we can load up programs on it, see what kind of games and what kind of programs were available for the system at the time, because that is, after all, how we can get a true flavor of what the system is capable of. Now, remember I was telling you the only thing I could have done was power cycle to stop that hello? Well, in fact, if I had pressed the initialize program, it would have done the same thing. So there you go. We learn something new all the time. Anyway, what I was saying we'd do was put programs on this thing. Now, when I bought this, it was cheap, so I snapped it up. But I didn't realize that this couldn't be connected up to just any old tape recorder or sound device. I thought that I'd be able to load a WAV file onto it and test it out that way. But as it turns out, it's an awful lot like the Commodore 64. Thomson were doing an anti-piracy thing, and you had to buy their particular data set in order to load with their real tapes. And the reason for that was their data set was using a kind of a stereo configuration. So what we had was we had 2 lines of data. One was pure audio that you could hear through the television, and that was for us, so that when it was loading up the program, we could hear that there was something happening and we were happy. The other one, however, was a TTL logic signal that was fed in through the data pin on the cassette port, and that was used to program the actual computer itself. So unfortunately, you can't just take that TTL signal and pipe it in as audio and make a program load. All you'll get are errors and all the rest. So what you need to do is you need to build a little device in order to transfer or to convert audio to TTL data. But even using that, it's fraught with pitfalls because conditions have to be optimal. You have to have the volume levels just right, and you have to have the frequency of sound just right, and there's many other little bits and pieces you have to have right as well. Now, I was looking around on that site I mentioned that escapes me for the moment, but is in the description, that told me all about the power supply and all the rest. Fantastic site that covers everything on the Thomson computer. It was there also that I found that audio to TTL converter, but they have an even better thing that's been updated all the time, and it is called an SDMOTO device. Now, I built the version that came from way back, like 2012, because I had the parts to build the older version, and also this is an older system, so it doesn't really make use of the newer functionality of the newer versions. But anyway, what am I talking about? Basically what it is an SD card reader plugged directly into the cassette port on this. Thomson will see that as a disk drive and use it that way. But any computer that uses a disk drive needs disk controller firmware, and the Thomson is no different. So I've got this guy here, which is our little communications box, the Nano Rizzo guy that I showed you earlier, which is of no use to me because I don't have a network. And what we can do with this is we can open it up, pop out the little chip that's inside of it, and replace it with a chip that I programmed myself with the controller firmware. And then when I plug it into the back of the Thomson, and I have my little SD card reader plugged into the cassette port, as soon as I power on, I can load up any software that I have programmed onto that SD card. Okay, so I've got to say, hands down, of all the retro systems I have, of all the systems I've tried to put software on, this is probably the easiest of all. Because this particular setup, the SDMOTO thing that they've developed, is really, really easy. All I needed was this little SD card reader, and the only soldering I had to do on it was to join CS to ground. And then what I did was I kind of cheated to accelerate the thing to go a little bit faster. I took 5 female to female 2-point cables, and I removed the plastic connector from one end. So I just plugged the female end that I had into the SD card reader here to connect that up. And then the bare metal that I was left with when I removed the plastic connector on the other end, I shoved into the DIMM port. There's 4 wires go into the cassette, and then 1 wire goes into the light pen adapters so that we can actually rob 5 volts from that to power the SD card. Now, as I was saying before, this SD card will be seen as a disk, but we need a disk controller in order to be able to access it. So I have programmed up a little chip, and it's in this little Nano Rizzo box now, which is functioning as a disk controller more or less. And in theory, when I plug this into the back of the system and I power on, I should get a menu. And there we have our little SDMOTO menu. Now, there is one file that has to be on the SD card in order to get this to work properly, because what happens is when we power on, the first thing that happens is the computer, because of the ROM in this, goes looking on disk for a file called SDMOTO.cell. And once it finds that file, it runs it. So SDMOTO.cell is copied onto the SD card here, and it is the program that runs this menu. So all the other files here are games or applications afterwards, and you'll notice that they're in SD format, which is a special format that was developed for this system. So there are all kinds of tools that will allow you to convert floppy disk images into SD. So I mean, there's only about 200 different games or whatever available for the Thomson, but they're pretty much all available in the SD format, so you can pretty much run any software that was made for this system using this particular thing. Now, I'm going to show you this first game I have here called Vampire.sd. I just press enter and it should load up. And the reason I want to show you this is that the first time I saw the Thomson MO5 anywhere, it was running Vampire, and I said, if ever I get me any branded Thomson, the first thing I want to do is run Vampire on it, because I always set myself stupid little challenges like that. Now you'll see that loaded up in 10 to 15 seconds. On tape, it would take up to 3 minutes to load this same game. So you can see the advantage to this system straight away. Now, just looking at the screen, it reminds me, and I know I've spoken about it an awful lot in this video, but it reminds me a lot of the ZX Spectrum, because, I mean, I suppose there are probably systems that are pretty much on the same level as regards power, but what's more, it's a little bit better in a way in that there's no color clash whatsoever, at least graphically speaking. This game itself is in French, as most of these games are. You see here we have manette, clavier, and jeu. So that's to let us pick between a joystick, the keyboard, and then finally to play the game. So we have keyboard selected. I don't have a joystick for it, so that's what we will do. I press enter and we start our game. So I'm this little vampire down here standing by this gate, and I can go left, I can go right, and I can fly. And also the spacebar will let me pick up objects and use them. So this game is a lot like Dizzy in that way. You see over here, for example, there's a gun. So we'll pick up the little gun here. We have that in our inventory. And very much like Dizzy, now that we have the gun, we can go around and we use it somewhere to get past certain obstacles. So you'll see there's this little guy down here at the bottom. Fall on him, press the gun, and it kills him. And that's one little puzzle, I suppose, solved. And then I can move on again and pick up more stuff and whatnot, figure out where to use it. The other thing is, this little moon here is constantly setting as we play the game. So I suppose, seeing as he's a little vampire, the last thing we want is that the moon sets before we've finished whatever it is we have to do. So, yeah, that's pretty much that game. In order to get out of it, we press Initialize Program, and usually it'll bring us back to this menu. Sometimes it brings us into Basic. But yeah, that's basically pretty much that. So that's pretty much all I have to show you on the old Thomson for today. I may well do a video where I'll show you just a quick montage of some of the games maybe in the next coming week or so, but there won't be a whole lot to it, but just to give you a little flavor of some of the games that are available for it. Okay, so there you have it. Another episode of 8 Bits in the Basement is drawing to a close. Except that it isn't, because I said I was going to show you the inside of this unit and I forgot all about it. So we'll get to that right now. Now, so as promised, I have opened 4 screws on the bottom of the system. I flipped it over and I've removed the top case. Now you'll notice that I'm not removing these mylars here because I'm terrified that I'll break them. And I've done it before to check the board. I'm not going to do it again because unfortunately, if these get broken, there aren't replacements being made for this. You won't be able to come across anything new that you can fix it easily with. So I'm just going to try and avoid disaster that way. But looking over this board, what we have is we have our reset button here. We have our cartridge port here. This guy here is our TV out. So this is where the cable for the SCART socket connects into, and it's very easy to remove, so you could change that cable quite easily. We have our barrel jack for power here. We've also got some form of voltage regulator here with a big heat sink on it. There's another one right here. And the system only actually has 5 capacitors in it, or 5 electrolytic capacitors in it. We've got 2 here, 2 here, and 1 over here. So I had a look at those. They're not leaking, they're not bulged or anything, so I'm happy enough to leave them as they are for the moment. While I'm using this system, I will eventually replace them, I'm sure. Now, as far as chips and that on the system goes, there is only one that is proprietary to Thomson, and that's this guy here. That is their ULA. So any of the other chips on the board can be bought off the shelf and replaced easily. This guy, however, can't. I don't think they're available anymore. So if something goes wrong with that chip, the system is pretty much toast, apart from buying another one to swap a new ULA into this. But apparently they very seldom fail, so that's a good thing. What we have on the board otherwise, though, is we have our memory here. It occupies 6 chips here, and each of these is 8 kilobytes. So we've got our 48 kilobytes of RAM here. We've got 32 kilobytes for the system, really, and 16 for the graphics. And this guy here, actually, the ULA, controls the light pen, and it controls graphics, and it controls 1 or 2 other things as well. But for the image we see on screen, this is doing all the heavy work there. This guy here is a 6809 processor running at 1 megahertz, and that is the same type of processor as you will find in a Coco 2 or in a Dragon computer. Over here we have our interface adapter, I think it's called. Yeah, peripheral interface adapter. So this guy here, his job is to communicate with any peripheral devices or whatever so that they can communicate with the processor and be used. That's what that guy does. And here we've got a 16 kilobyte ROM chip. So 12 kilobytes of this is occupied by Microsoft Basic, and 4 kilobytes is for the basic monitor. Now, I did go as far as to remove the motherboard. There's only 2 screws holding it in place, and I inspected the bottom of it to see that everything was okay, and everything was. So as I say, I'm not going to go removing these again because they were a nightmare to put back in. And that is, as promised, the inside of the unit there. So I guess it's time to move back to me to finish up. So now, another episode of 8 Bits in the Basement is really drawn to a close. But there is, as always, time for a joke. And this time it's another Star Trek one. And it's another ears joke, because I really like the ears jokes. So here we are. If Spock has pointy ears, then what does Scotty have? Engineers! Because he's an engineer. It's good, isn't it? I should start a comedy channel, I think. This is brilliant. What you do, give us a thumbs up and subscribe, because I know you loved it. I know you did. Anyway, look guys, if you enjoyed the video, leave us an old comment. You know the drill on the rest of it. Great talking to you once again. I'll be along with another video in a little while. And until then, take very good care of yourselves. We'll talk to you all very, very soon. PD out. Bye-bye.